In the previous session, we saw how we can create arrays, how we can perform basic operations on the arrays in NumPy. So in this session, we will see how we can manipulate these arrays, how we can extract some elements of the array through indexing and slicing. So let's first discuss what is indexing. See, array indexing refers to the use of square brackets. So like this, in order to index the elements of the array, so that we can refer individually the elements and extract the values. We can select the items and even assign values to the items. So when you create a new array, an appropriate scale index is automatically created, and if you want to access a single element of an array, you can refer to it by its index. So the figure 3.3 shows the indexing of an n-dimensional array. So this is an array which is created, which has the elements as 10, 11, 12, 13, 14, 15. This is a unidimensional array. So the indexes, if you start the indexing from the left hand side, similar to list, the indexing starts from 0, 1, 2, 3, 4, 5. If you try to access the elements from the right hand side, then you have the negative indexing concept: -1, -2, -3, -4, -5, -6. So let's first try to create a unidimensional array, and we have discussed in the last session how we can create it using the arrange function. So when I say np.arrange and I give two arguments 10, 16, the elements, the first element would have the value 10, and sequentially it will increment by 1 till 15. So this is the array which is actually created. Now if you want to access a particular element, let's say I want to extract the number 14 from this array, then you have to specify the index. So what is the index? If I am using positive index concept, 14 is at the index number 4. So if I just type A4, 4 has to be specified within the square brackets, then the value at that index will be extracted. If suppose I use a negative index concept, then I have to start from the right hand side. Suppose I want to access the number 15 using the negative index, then I just have to type A of -1. Suppose I want to access the number 10, then I have to write A of -6. So let's now see how we can select multiple items. So previously what we saw here is we were accessing single element from the array. So if we want to select multiple items from the array, then you can write multiple indexes. Okay, so suppose I want to extract 11, 13 and 14 from the array. So what are the respective indexes? 1, 3, 4. So within square brackets, double square brackets you have to give, right? 1, 3, 4. So these are the indexes. So what happens? The elements at the index A of 1, element at the index A of 3 and element at the index A of 4 will be extracted into a new array. So every time, as we saw here, a new array will be created and a scale index will be automatically created to it. So now this is a new array which is created, and for this also you will have the index 0, 1, 2. Suppose I am creating a two-dimensional array as shown in the figure 3.4 here, then axis 0 will represent the rows, axis 1 will represent the columns. Okay, so that means what? If you see this example here, let's first create the two-dimensional array, and the format is np.arrange. I am using reshape function to say what is the size of the array. I am trying to create this array, so the size is 3, 3, and I want to just give sequential elements. So since I want to give sequential elements, if you just write 10, 19, then what happens? Numbers from 10 to 18. So exactly 9 numbers would be filled: 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is the array which would be created. Now from this two-dimensional array, suppose I want to access a particular element, let's say this 15. Then you just have to specify both the row number as well as the column number. So that would be A of, what is the row number? That should be the first. The first number would be the row number. So 1, and second number is a column number 2. So if I write A1, 2, then the number 15 would be you would be able to access. So coming to the next thing, in order to extract portions of an array, we have to go for slicing. So before we go for slicing, let's just demonstrate this on the terminal. Let's go to the Anaconda terminal. Okay, so as we have already seen, I am already in the Anaconda prompt, right? So before I start writing the code, you can see that I can't write the code directly here. So once I am in the Anaconda path, here you just give the command Python. So now I should be able to give the commands. Let me increase the font size. Okay, so now you got this prompt for entering the command. So let's first import the NumPy. Import NumPy as NP. Now it is successful. Now let's start creating the array. Let's create a unidirectional array first. Let's say a is equal to np.arrange. Similarly to this what we had in the presentation here, let's create a unidimensional array with the elements 10 to 15 here. Okay, so np.arrange 10, 15. So I want 10 to 15. So that means one number should be more, right? So 10, 16. So now if you just display A, you can see I have created numbers from 10 to 15. We discussed how arrange function works in the last session. Now if I want to access a particular element, let's say I want to access the number 14 here. So what is the index? 0, 1, 2, 3, 4, right? So if you just type A within square bracket the index, you can see that I am able to access the number 14. Suppose I want to access the number 12. So what is the index? 0, 1, 2. So A of 2. So 12 is displayed. Now what about the negative index? It would be -1, -2 like that, right? So if I want to access the number 15, I just have to type A of -1. If I want to access the number 10, then it would be -1, -2, -3, -4, -5, -6. So just type here -6. Okay, so this is a negative index concept. Now suppose I want to access multiple elements. So let's say I want to print 11, I want 13, I want 15. Then what I have to do? What is the index of this? 1, comma. 13 index is 0, 1, 2, 3. It is 3. And 15 is 5. See, now I have access 11, 13, 15. Okay, so to access the multiple elements, suppose I want to access now 10 and 12, then what I have to type? Open the square brackets. 10 is at the index 0 and 12 is at the index 2. Okay, there was an error in the square brackets. See, so that's it. So this is about indexing. Suppose I want to create now a two-dimensional array. So how can I create a two-dimensional array? Go to the terminal again. Okay, so let's create a two-dimensional array. A is equal to np.arrange function. Now I want to give elements from, let's say I want to create a 3 cross 3 elements. Suppose I start giving the elements from 15 sequentially. I will need 9 elements. So that means 23. Dot. I have to give the dimensions of the two-dimensional array. So that would be dot reshape 3, 3. Okay, so now press enter. Okay, I think we missed giving one element here. It should be 24. Yes, so now the three-dimensional array is created, two-dimensional array is created. So now within this, suppose I want to access the element 20. So what should I give? A of, within the square brackets, I have to first give the row number and the second element would be the column number. See, this is row 0, 1, 2. This is column 0, 1, 2. So 20, the element 20 is at the row 1 and column 2. See, 20 is displayed. Suppose I want to display 21, then it is in column 2 and column 0. See, 21 is displayed. Fine. So now let's go for the next topic. So this was about indexing, where you create the array and access a particular element, or you can access even multiple elements. So now let's go to slicing. Now what is slicing? Now from slicing I can extract portions of an array and generate a new array, right? So we saw a similar concept like this even in list, where what happens for the slicing in list is it will actually make copies, but in NumPy when you do slicing in the arrays, it will make changes in the same array itself. A new array is not created. So that's the difference. But the concept remains the same. We are going to extract a portion of that. In this case, we are going to extract a portion of an array, right? And generate a new ones. So when you want to generate or extract a portion, that portion would be separated by colon within the square bracket. So here also you use square brackets, but you need to give the starting portion or the ending portion, that would be separated by a colon. So let's see this example. Here we have created a unidimensional array called A with these values. So I want to slice out a portion. Let's say I want to slice out from 11 to 15. So within the square brackets write 1 colon 5. So basically it's the index, right? So 0, 1, 2, 3, 4, 5. So that's the index. So 1 colon 5. So then what happens? A new array is generated here, and this is a sliced out part of the array. Now it need not be that you have to extract in a sequence. Suppose I want to extract different portions of an array. So then you can use a third argument, right, as shown here. So the first argument, as usual, it will indicate the starting index. The second argument will indicate the ending index. What does the third argument do? It will define the gap in the sequence of elements. Okay. So what happens in this example? It will start from index 1. So index 1 is 11th element. Which is the last element? 5. So which is the fifth element? 0, 1, 2, 3, 4, 5. It will go up to this. So it is trying to extract from 11 to 15. But I have given a gap of 2. So what happens? First 11 will be extracted. Then 13 will be extracted. Then 15 will not come, because as per the concept of slicing, this will not come. Okay. So let's first try this in the system. Let's first try to create a two-dimensional array. A is equal to, let's create a np dot arrange. Let's give values. Let's say it starts from 10 to, we are going to have 9 elements, 19 dot reshape. Keep the shape of the array. So this is our two-dimensional array. So I want to extract a portion of this. Okay, let's first start with the unidimensional, then we'll go for the complex one. Okay, let's first create a unidimensional array. Okay, so this is our unidimensional array. Suppose I want to extract from 11 to 15. Then what you have to do? A of 11 is at the index 1, 1 comma 15. So 1, 2, 3, 4, 5. So 5 is the index. Too many indices for the array. So what is the problem here? Yes, I did not use the colon. It should be separated by a colon. So what has happened here? We have sliced out a portion of the array 11, 12, 13 and 14, because the index is 0, 1, 2, 3, 4. So I have extracted elements from the index A of 1 to A of 5. Now suppose I want to extract I want to extract elements from 1 to 5, but at the gap, particular elements only I want to extract. Let's say I want to extract only 11 and 13. Then what you can do is use a third argument and specify 2. Then what happens? It starts from 1, it goes up to this 15, but at the gap of 2. So 11 and 13 will be displayed. Okay, so basically the third element will specify the gap. The first argument will specify what is the starting, basically it will tell the element at that index, so a of 1. The second one will tell the element at that index, that is a of I, and 2 will actually tell you the gap between these sequences. Now, so there are, you can take slicing a little more further. Suppose I do not specify the first argument, then by default it will be taken as 0. So in the sense here, the same one, let's say here I don't give the first argument. So then what happens? It will take it as 0. A of 0. So that's why what has happened, A is actually this one. So since I did not specify the first argument, by default it will take the index as 0. So 10 also got printed. The next one, if you omit the second number, if you don't specify the second argument, then it will take the maximum index. So let's change this. Suppose I say 1, 2, I don't specify the second argument. So then what happens, it will start taking the elements from A of 2 and it should go up to the end because I did not specify the second argument. So remember this, if you do not specify the first argument, by default the index will be 0. If you do not specify the second argument, by default the index would be the maximum index. Now the third thing, if you omit the last number, that will be then all interpreted as 1. That means a third argument which I'm talking about. If I don't specify the third argument, then it will be considered as 1. Okay, so that means what? This one, right? So we did something like this. Now instead of 2, if I don't give anything here, then what happens? It will take it as 1 only. So basically it is telling that the gap between the elements is 1, or it is sequential, in other words. So in this case, what kind of output you should get? You should get the values from A of 1. It should go up to index 5, 1, 2, 3, 4, 5 at the gap. So sequentially it should print all the elements 11, 12, 13 and 14. So these are the 3 points that you have to remember. If the first argument is left out, then the index is 0 by default. If the second argument is left, then the argument is the maximum index of the array. If the third argument is left, then the gap is taken as 1. The same concept is demonstrated here. Now, suppose now we extend this concept to two-dimensional array. Okay, so how do you extract it? Suppose I don't specify, I just want to extract only the first row. Then just give 0, colon. If I want to extract only the first column, then give colon, 0. So what does it mean? If I just want to extract the first row is what? Row 0. So don't specify anything for the column. So let's first create a two-dimensional array. See, already we have a two-dimensional array. So now if I want to just extract the first row, then what should I do? 0, colon. So when I do this, I see I'm extracting only the first row. If I want to extract the first column, I have to just reverse it. Colon, 0, because colon means what? All the rows. Colon, if in the sense all the rows. So what happens here? All the rows, it will take all the rows, and since I said 0, 0th column. That's the meaning. Okay, so when I say colon here, all the rows are taken, and since I said 0, 0th column. So all the entire first column is printed. Now if you want to extract a smaller matrix, right? This is a matrix here. I just want to extract 10, 11, 13, 14. Then what you have to do is, see, suppose this is our array. Right, this is our three-dimensional array. Now I only want to extract these elements. Okay, so that means I want to extract the elements from the 0th row and the first row, and 0th column and first column. So in that sense, what I have to do here is, then I have to specify both the row and the column. So what you do is 0 to 2 I want to extract, comma, again 0 to 2. See, then what happened? 10, 11, 13, 14. Because I am taking the 0, row, first row. 2, when I say, what happens, it will not consider that. Okay, so what is happening is the first value is actually the row. So when I say 0 to 2, it will take 0th row and first row. When I, in the second argument, when I say 0 to 2, it will take 0th column and first column. So that's the way it is. Now suppose I want to extract, let's say 10, 11, 16, 17. This one, 10, 11, 16, 17. Then what do I do? See, this is our array, right? This is our initial array. I want to extract 10, 11, 16, 17. Then what do I do? Now you have to explicitly tell, right? I want 0th row, I want the second row, and 0th column and second column. So what do I do here is I put commas here. That's the difference, right? So 0th row and second row. That would be my first argument. Okay, and my second argument would be, I want the which one I want? 10, 11, right? I want both, right? So here it is continuous, right? It's because I want 10, 11, 16, 17, then I can just type 0 to 2 like this one. That can be done because it is anyway sequential. See, what does this mean? When I type something like this, I am taking the elements from the row 0 and from the row 2, and coming to the columns, I am taking 0th column and first column. You need to try this. When you keep trying, you'll get a hold of what I actually mean by this. So that's it. So in this session, we have tried to understand indexing in arrays. We have tried to create a unidimensional array. We have extracted the single arrays, single elements. We have used negative index concept. We have tried to extract the two-dimensional array. Then we did the slicing, where we tried to extract from a unidimensional array. We also tried to extract from the two-dimensional array. So try these. These are very important concepts and very commonly asked in interviews. Try this in the Anaconda and to get a more hands-on on this. So in the next session, we will be discussing about iteration, how we can iterate through the arrays. Thank you.